right, now that we have a firm understanding of what a function is, it gets a little more streamlined from here. We can solve for any inverse by simply inverting the function and solving for y. So let's check out example 3 here. Find the inverse, f inverse, of the function f of x is 2x as x squared minus 1, and then determine the domain over which it exists. Now that part we'll come back to. Why on earth would we have to talk about domain? But let's first find the function. Okay, so we're going to focus on this first half right now in purple. Well, f of x, excuse me, is x squared minus 1. Right, that's what we have there. Again, f is a great use for naming things, but it kind of gets in our way when we want to invert stuff. So let's just go back to y. And now we will do the inversion step where we actually switch x and y. Then we will solve for y. Now in the last video, that solving for y is very easy. All we had to do was divide by 3. But let's go step at a time here. We just finished a chapter a little while ago about formulas, right? And so technically all we got to do is solve for y and pretend that x is just another number. So how would I solve for y here? I'm going to add 1 to both sides. I get x plus 1, pardon me, is equal to y squared, because these cancel, right? Chose that because I want to get rid of the minus 1. Now I want to get rid of the square, so I will square root, and we get the square root of x plus 1 is equal to y. And so our f inverse of x is equal to the square root of x plus 1. Fabulous. Okay, we found our function. And it's a beautiful function. We just saw in the last chapter, you can take the square root of x plus 1. It's very nice. But what happens with this domain part? Why on earth would we consider the domain of the inverse? When we were back with the linear, everything switched beautifully. But let's look at a quick graph of these two. I'm just going to go ahead and go to Desmos. You don't have to write this down. But if we go to the Desmos app and we look at both of these functions, maybe. Okay, there we go. Sorry about that. If I plug in these functions, x to the second minus 1, we get a nice parabola, right? Which makes sense because that's a quadratic. And then we invert it and we do the square root of x plus 1. Well, what happened? Look at those. Shouldn't there be like a second half, a bottom to that graph, right? Shouldn't that be the case? Well, remember, there's something weird about square roots. So let's go take a look at this square root function a little more. The domain of the original function is fine. You can plug in whatever you want. But what do we know about square roots? Why is there no bottom to this function? Oh, that's right, because that cannot produce a negative number. Oops, number. That can't be negative. It doesn't spit out a negative number. That's not how radicals work. Otherwise, it wouldn't be a function. We couldn't call it f inverse of x. We'd have to call it like y, because that's not a function. And so we need to state that this domain only has positive numbers. That you can only plug in certain numbers that will result in positives. And so we want to say that square root of x plus 1 has to be bigger than 0, right? So if that's the case, well, what does x have to be? Let's square both sides. We get x plus 1, still 0. X has to be bigger than 1. It could be equal to. That's fine. X can be bigger than or equal to 1. It cannot be less than that. And so we say the inverse of the domain, the domain of the inverse has to be 1 or greater. And remember, that's how we'd write that in interval notation. Including 1 is okay, but then on its way to infinity is also okay. It just can't be anything less than 1. All right, cool. And now that doesn't happen every time. It's not every function that we have to worry about this, right? The linears had no problem there. You could go positive, negative in every direction. It's just really when you get into those square roots, you'll see something with the rationals, right? And we'll just talk about it quickly. All right, let's take the next 3 examples a little bit faster so that we can, because they're basically the same thing. So find f inverse of x of the function f of x equals 3x squared minus 5, and to determine the domain. So we'll kind of give ourselves 2 sides here. Here's our original function, 3x squared minus 5, right? And we'll change that back to y just for convenience sake. Now, some classes, some advanced classes, you'll see it leave it in function notation. To me, that just ends up a lot of parentheses, and since it's exactly the same thing, I go back to y. Then we go ahead and invert. I like my dotted line to remind myself this is not the same function. Notice what happened here, though. I did not take the square with me. Okay, common mistake. Don't take the square. Don't make this x squared minus 3y. That's not what we want. We just want to change the letters. I think I'll do the exact same thing as if I was solving any other function. I start as far away from y as I can. So I'm going to add 5 here. Add 5. We get x plus 5 is equal to 3y squared. Now from here, I'd like to take probably the 3. So x plus 5 divided by 3 is y squared. And there's square root both sides. X plus 5 over 3. Now you are welcome to write over 3 as 1/3 x plus 5/3, right? You're more than welcome to split that up. But since everything's under the radical anyway, there's no point. All right. And that's our f inverse function. But remember, radicals still have that issue that they cannot spit out negatives. So let's go talk domain. Well, the square root of x plus 5 over 3 has to be greater than or equal to 0. That's still the problem. Same problem as last time. Let's undo this now. We're basically going to go back to what we started with. So square both sides, you get x plus 5 over 3 is greater than or equal to 0. Multiply by 3, x plus 5 is still greater than or equal to 0. And so it looks like x has to be greater or equal to -5. Now don't get confused. Yes, when you're dealing with inequalities, if you divide or multiply by a negative, that's when the sign changes. Here, it's just subtraction, so x is just greater than -5. So our domain would be -5 to infinity. Beautiful. Moving right along. What is our next function? Next function is another quadratic. So if you'd like to try g of x on your own, you're more than welcome to. I'll stop talking for about 3 seconds so that you can pause the video and then come back and check your answer. All right, hopefully you had time to pause the video. That way you can come back and check your answer, and that's what you're doing now. G of x is y equals 7 minus x squared. Invert the function. X is equal to 7 minus y squared. Now don't let this trip you up. I'm still going to subtract a 7 so that I can get rid of that positive 7. Now I'm going to divide by -1 and square root. And I have g inverse of x, very similar to the last problem. All right. The domain over which this one exists has the same issue as before. This radical cannot spit out zeros, and so it has to be greater than or equal to 0. Therefore, -7 plus x has to be greater than or equal to 0. Negative x has to be greater than or equal to -7. Now, here is where I will need to change the sign because I'm going to divide by -1. I'm sorry, yeah, -1 to get a positive 7 on the other side. Sorry about that. And so x actually has to be less than or equal to 7. So how does that change my domain? Well, now less than would be all the negative numbers up to 7 and including it. It can actually be anything less. So that will spit out a positive number. That would be our domain. All right, the last one for this video is an entirely different kind of function. This is a rational function. We are going to solve it the same way, though. Luckily, inverse, the type of function for an inverse does not matter. How you find it is exactly the same thing. You may have to make a few creative moves, but it's the same idea. R of x is 2 over x minus 1, and so y is equal to 2 over x minus 1. When I switch those, I get x is equal to 2 over y minus 1. Be careful, it's not x minus 1 on the other side now. It's just x. We just invert the x part, right? We just invert the x and the y. Here's where it gets a little trickier, though, right? We have a few higher level solving moves we need to use. Our first issue is that y is in the denominator, and so I'm going to have to bring the whole thing out. So I am not allowed to break that up. But now I've already fixed that problem. I no longer even have a denominator here. I just move it to the other side. Many people have a tendency when they see parentheses like this to go distribution. I must distribute. I must distribute. I actually say, nah, a better choice might be just get rid of the x. Just get rid of the thing that is not y and move it to the other side. That way you don't end up with multiple terms with x in it. It's not as constricted because x is not what we're solving for. We're solving for y in this case. Then I can just move that 1 to the other side, and bada bing, bada boom, I have my inverse function. 2 over x plus 1. Now, some people like to see patterns with rationals, and that's great, but at the end of the day, I recommend just solving and making sure your inverse is correct. All right, is there an issue with the domain? Well, remember, rationals, they can be negative. You can have negative fractions. That's okay. No big whoop, right? But there is a certain place that a rational would be an issue. Okay, so we're going to go back to Desmos. We're going to go back to Desmos now. We're going to take a look at these two functions real quick. We had 2 over x minus 1. And if you've never seen a rational graph before in your life, there you go. But notice there is a little place here at x equals 1 that it looks like this green line never hits this purple line. It's called an asymptote, right? This is the one place we cannot be, because remember, there's an issue with rationals. Rationals cannot have 0 on the bottom because it's a fraction, and fractions can't have 0 on the bottom. So did that apply to our inverse as well? Well, if I get rid of these original ones, 2 over x, but now on the outside is plus 1. There is still an issue. X cannot be what in this case? X is not allowed to be 0. Whoops, not x0. X is not allowed to be 0. It never hits that 0 line. And so I have to state that for my domain. Remember, I'm not just going to say the positive half, because we can see that there are things on the negative half. So I'm going to have to find a way to say everything but 0. So if I go over here, the domain is everything but 0. Little number line for us. Let's just write that x-axis down. Here's that 0 we saw. Everything over here was good. Everything up there was good. And so we're looking at negative infinity up to 0 and 0 to infinity was the domain for our inverse. Now, yes, there was also an issue with our original function domain. Sometimes you'll be asked about both. In this case, it's only asking the one of our inverse, and so that's the only one we are stating.